Right, hi everybody, welcome back again. This is the conclusion of topic 3.2, Origins of Biodiversity, second of two videos. Hope you remember that the first video was basically about the mechanisms which cause biodiversity to increase, which at its most basic level is evolution by natural selection. In this one, I'll follow it through to its logical conclusion, which shows you how evolution by natural selection leads a group of living things to split into more than one group of living things. And of course, we refer to those groups as species. Very quickly, to have a look at the key terms we'll cover here. It should be quite a quick one, I hope. Number one, speciation results from groups of living things becoming isolated from each other. We call that reproductive isolation. It means that they aren't able to spread the genes freely between these different groups. Because of that, they evolve to different selection pressures, often in different places. And because of these different selection pressures, they evolve differently through natural selection. If that's allowed to continue for long enough, they become so distinct genetically, the gene pools become so differently, then they become different species. They become different species at the point at which they are so genetically different that they can no longer reproduce together to form viable offspring. You know that definition already. And then basically I just want to talk about two reasons for speciation. Usually it's because of geographical separation, barriers existing between that split a group of living things into two or more groups of living things that are unable to reproduce as one group. These are examples that are given in the syllabus. I'll go over them again in a minute. It could be the formation of mountains that split populations, creation or changes in rivers that separate populations, sea level change, climate change, or plate movement, movement of tectonic plates around the planet. The syllabus asks you to consider this quite specially, plate movement and the effect it has on speciation. And then finally, not necessarily on the syllabus actually, but I think it's worth mentioning, reproductive isolation doesn't have to be geographical. It could be separation over time. And I want to give you one example at least of a group of living things that are separated not by geography, but because they reproduce at different times of the year, and therefore they are, we'd refer to that as sympatric speciation, which is temporal, which means over time. Reproductive isolation over time rather than geography. Okay, let's look very quickly, please, at the syllabus statements. Fairly short because we've covered most of it in the first video. First of all, the definition of speciation. It's the formation of new species when populations of species become isolated and therefore evolve differently. I've already said that. I've already mentioned these possible mechanisms or possible allopatric mechanisms of division of a group of living things. I won't go through that again now. Number three, the distribution of the continents has caused climatic variations and variation in food supply, which contribute to evolution. Well, we'll talk about that in terms of tectonic plate movement. And then finally, it asks us to consider why there have been mass extinctions in the past. So speciation generally occurs as new species occur due to this separation and therefore different selection pressures. But very often in the history of the Earth, there have been huge extinction events, certainly 5, and we may be living through a 6th, 5 that we know about, and a possible 6th due to human influences on the planet that we've already spoken about. And that's illustrated in the fossil record. Basically, species that exist in the fossil record in layers of rock suddenly disappear due to what we think are catastrophic events. I'll discuss what I know about that. And then finally, under application and skills, we're asked to explain how tectonic plate activity influences evolution, the formation of barriers, or maybe the coming together of plates, separation of groups of species, but maybe species allowed to come back again together, or groups of living things allowed to come back together because of plate tectonics. And then finally discuss the causes of mass extinctions. I'll do that fine at the end of the talk. Okay, these terms are not exactly on the syllabus, but I think it's worth mentioning. We normally talk about biodiversity increasing over time. That's the normal mechanism of evolution. We see more and more phenotypic variations occurring over time as more and more species form. One example was Darwin's observations of finches on the Galapagos Islands near Ecuador during his voyage on the Beagle. He discovered that on each island he saw different variations of finches, different species of finches that were caused because of this isolation of original ancestor birds that actually came from the mainland. Another example is the Pentadactile limb, the limb that exists with 5 digits basically. Exists in all kinds of animal species, frogs, lizards, birds, but you can see how the shape of the bones has changed due to divergent evolution, due to its different uses. The wing of a bat, the arm and hand of a human, the flippers of a whale perhaps, or the wings of birds. These are examples of evolution occurring divergently, or the spreading of different forms. But evolution can also act convergently. That's when selection pressures change and might force a very kind of different group of species or a different group of living things to kind of come back towards one kind of overall form, or one kind of similar form. So here's an example of different eagles. These are all different species, but because they inhabit this very similar niches, the selection pressures are very similar, and therefore they've kind of forced them towards one kind of form. You have to be quite an expert in eagles to be able to see the difference between these species. This is a steppe eagle, tawny eagle, and a Wahlberg's eagle. Very, very similar in form. Another example is the flying animals. Because they occupy the same niches, not necessarily at the same time. In the case of these are pterosaurs, flying reptiles. Because the selection pressures were similar, it kind of forced them back towards a very similar form. And another example here is the Ichthyosaurs. This is Ophthalmosaurus. It lived in the Jurassic period. Very, very similar in form to a modern day dolphin, because they inhabit very, very similar niches, and therefore selection pressure kind of forces them back towards a very similar kind of form. I'll leave you to make your own mind up about the last one though. Okay, moving on then. All right, so speciation, these are more or less definitions. After a disturbance, new habitats are recolonized by existing species. We talked about this in terms of succession already. Those ancestral species get there to the new habitats by swimming or floating, flying in some cases, or floating on air patterns, especially insects and spiders, for example, by walking, hitching, I should have said that maybe floating on vegetation as well, and reaching this new uncolonized area. If these new organisms are left in a state of isolation over time, they're acted on by different selection pressures. And because of those different selection pressures, and because of the underlying mechanism of mutation, 2 different gene pools, or more than 2 different gene pools, arise therefore that are very different, that over time become very different to each other. Given enough time, as I've said before, this leads to speciation, which means the gene pools are so distinct that those 2 groups can no longer interbreed with each other and produce fertile offspring. That's the definition of a new species. These are the examples given in the syllabus of geographical separation, or barriers that mean that these 2 or more groups of originally the same species can no longer intermix and therefore breed freely, and therefore are acted on by these different selection pressures and different rates of mutation. Formation of mountains, changes in river flow or direction, changes in sea level, climate change, which might be linked to changes in sea level, and movement of tectonic plates. Right, then I said I would return to talk about sympatric speciation, or isolation not due to geographical barriers, but due to barriers in time. This is very rare, actually. One kind of well-documented example occurs in fruit flies, specifically apple maggot flies. So the ancestral group of these fruit flies laid their eggs on hawthorn fruits. Now, over time, possibly due to mutation, females, or some females I should say, had developed a preference to lay eggs on apples rather than hawthorn fruits. So then you started to get two separate groups of females, one that preferred to lay eggs on one fruit and one that preferred to lay eggs on another fruit. Now these fruits ripen at different times. So therefore, due to this preference of females, you ended up with one group of males and females breeding when the hawthorn fruits ripened, and one group of males and females, originally of the same species, mating when the apples ripened. Over time, because of different mutations in these two different groups, they became genetically extinct and eventually formed two different species, the apple maggot fly and the hawthorn maggot fly. So this is an example of where all of these animals basically exist in the same geographical area. They're not separated by geographical barriers, but they're separated by a barrier in time, which led to different mating times. I think the apple ripens earlier, so therefore those individuals that prefer to breed on apples no longer mated with those individuals that prefer to mate on hawthorn fruits. I hope that made sense. We'll go back over that in the classroom. That's sympatric speciation. Okay, then moving on to the last part of the syllabus statement. It asked us to consider the effects of plate tectonics in speciation. Plate tectonics is a fairly recent addition to scientific knowledge. Originally suggested by Alfred Wegener in 1912, but only really adapted much later, I think the 1940s onwards. So it's the idea that plates or crustal plates on the Earth kind of move around fairly freely. This means that if they're moving, species that originally developed on one plate can be split apart due to the plates moving apart, and therefore have different isolation pressures as they move apart. Reproductive isolation occurs, allopatric speciation occurs, and therefore we get different species but from the same ancestors. This explains why we get marsupials basically in two parts of the world, in Australia and South America, because originally those two plates existed together, and it existed as basically groups that weren't originally reproductively isolated. I'll show that in a diagrammatic form. Here we can see where some of the kind of fossil species of plants and animals originally existed. We find fossils in South America and Africa in this kind of strip. Across the Indian subcontinent, with these Triassic reptiles across Africa and Antarctica. In this case with this plant, they existed through Australia, Antarctica, and then onwards through Africa and through South America. This is the original continent of Pangaea, when all of the landmass existed together before they moved apart. Hope that made sense. Okay, and then finally, how does plate movement influence speciation? We've said this already. Plate movement is responsible for the formation of mountains, huge valleys, rift valleys that individuals are not able to cross in many cases, or even the formation of oceans. We see that as the Pangaea continent started to drift apart. They're all examples of allopatric speciation. However, what can also happen as sea levels change or continents drift together, as happened with the Indian subcontinent and South Asia, some of these individuals can come back together again. So originally isolated, but come back together. If they've not undergone speciation, more likely they have, because this happens in such a long time period, they come back together again and live together without reproductive isolation. Plates, as they move, can move through new climatic conditions. As they move north or south towards the equator, away from the equator, and biomes can change over time. So originally Antarctica was very close to the equator, but it's moved south to the poles, and therefore that changes very much the species that are able to survive there. And then finally, one final thing that occurred to me, subduction also occurs. Subduction is where one plate moves underneath another one, synonymous with very high volcanic activity, and that can destroy habitats as well, as can volcanic activity across fault lines. Okay, I'll leave you to come up with your own kind of version of that. I don't think I've explained it very well there, but you can consider a bit more clearly, I think, how plate movement or continental drift can affect speciation. We can discuss that in the class. And then finally, the final thing that we're asked to discuss under the applications in the syllabus statements is this idea of mass extinction. So we know that biodiversity generally increases due to adaptive radiation or divergent evolution, but at times we get these massive catastrophic events that lead to huge losses of biodiversity, huge losses of species. Okay, over the fossil record in the past, we can see evidence of 5 mass extinction events. That's not to say that there aren't more that haven't been discovered, but at the moment we think there are there's evidence for 5 major extinction events. With the exception of probably the final one, the Cretaceous Tertiary extinction, which was responsible for the death of the dinosaurs, the mechanisms are not that well understood. I'll tell you a little bit about what I know about each one in this section. So first of all, the Ordovician Silurian extinction, approximately 443, I think, million years ago. In this extinction event, from the fossil record, we know about 85% of all species on Earth became extinct. Consider how long ago this was, though, and you could also might also realise that at that time, basically all species that were alive lived in the oceans. So this is a catastrophic event that affected the oceans. Also consider there were much fewer species actually around then, because there was much less time for a speciation to have occurred. So as far as I know, scientists at the moment think this was caused by a huge global cooling event, basically a major global ice age, created possibly just to the natural variation in the orbit of the Earth around the Sun. It seems like sea levels were reduced, and because so many species, all of the species lived in the ocean at that time, the reduction in sea level and global cooling was basically responsible for killing off those species, or at the very least making fewer and fewer niches available for fewer and fewer species to be able to survive. I think there was a second wave of extinction actually. There wasn't just one wave. I think it happened over 100,000 years or so. So there was a second wave of extinctions when the Earth started to heat again as the orbit of the Earth changed again. Also remember that at this time, the continents, because of continental drift, were in very different positions at that time, largely around the equator. Okay, number 2 is the Devonian extinction about 365 million years ago. Now, as far as I know, the causes of this event are very, very unclear. Possibly again global cooling, moving towards another major ice age. Possibly huge volcanic eruptions. That's another possible mechanism. Some scientists are saying that there's a possible meteor strike, although the evidence, because it was so long ago, is very, well, not much evidence for a meteorite strike. Number 3 is the Permian Triassic extinction, 250 million years ago. This is the start of the age of the dinosaurs. This is probably the greatest extinction event of Earth's history. At that time, 95% of all marine species are thought to have died, and up to 70% of terrestrial species. There were terrestrial, largely reptile species around, and other species around at that time. It seems like a meteor strike is the most likely, although the evidence is not overwhelming for that. And again, it occurred over a very short time period in terms of geological history, about 100,000 years ago. As I've said, it led to the rise of the dinosaurs, the rise of the reptiles. Number 4, the Triassic-Jurassic extinction. You may not have heard of this, but there was basically 2 extinction events during the time of the dinosaurs. This was the first. It wasn't as big as some of the other extinction events. We know that species of crocodiles survived, along with species of dinosaurs and the pterosaurs. Largely affected land-dwelling species. And again, it seems it was due to some kind of gradual climate change, although the mechanisms are not that well known. And then finally, probably the one of these 5 that you're kind of aware of was the Cretaceous Tertiary extinction 65 million years ago, which was led to the death of the dinosaurs. There was some debate until fairly recently about the causes, but most paleontologists now seem to agree that it was because of a meteorite strike or a comet strike, perhaps. And this is where we do have evidence, because there is a huge crater in the Gulf of Mexico that seems to have occurred at that time. There are bits of Mexican rock around the whole globe, in Europe, for example. And the outline of that crater is visible because it outlines the cenotes in the south of Mexico. It seems to have occurred around the Gulf of Mexico. Sometimes scientists stick to this idea of huge volcanic eruptions occurring at the same time, but I think the majority of paleontologists now agree that it was due to this meteorite strike, of which we have evidence. Okay, and then finally, I should also say, by the way, that the loss of the dinosaurs opened up new niches, and when new niches become available, new species start to colonize those niches. The end of the dinosaurs signified the rise of the age of the mammals, because the mammals started to occupy the niches that the dinosaurs had previously occupied. Okay, and then finally, I'll just finish this by saying there is overwhelming evidence, actually, that we're currently living through a 6th mass extinction. Species are becoming extinct now, as we speak, basically at the same rate that they were going extinct during the time of the Cretaceous Tertiary extinction, 65 million years ago. And that is actually likely to accelerate if we don't really do something about it certainly during your lifetime. This 6th extinction is not due to natural events like the others, but overwhelmingly due to the actions of humans. And we know about the 5 ways that humans are reducing biodiversity at the moment. I hope I can remember. Number 1, habitat destruction. Number 2, islandization of habitat. Number 3, overharvesting. Number 4, pollution. And number 5, in no particular order, introduction of alien species into existing habitats. Okay, everybody. I hope I didn't go through that too quickly. I tried not to. Basically, I want you to go away from this understanding that speciation is a result of a group of living things becoming isolated into 2 or more different groups that are unable to reproduce together anymore. And those barriers may exist allopatrically due to geographical separation, or sympatrically due to separation over time. And I gave you examples of all of those. We look at more specific examples in the classroom this week. Okay, so as usual, look after yourselves and your own health, please. Take care, and we'll speak in the classroom this week.